This module, we're going to be talking about shading. So shading a solar cell is similar to introducing a clog into a pipe of water. That's right, we're back to the water example, guys. The clog in the pipe restricts the flow of water through the entire pipe. Similarly, when the solar cell is shaded, the current through the entire string is reduced. So if one cell is shaded, out of normally 60 to 66 cells in a panel, and one of the panels in your solar array is shaded, the overall output of the system could drop as much as 30 to 40%. Much like a clogged pipe or a kink in a hose, if your current is flowing through your solar panels and it's interrupted by a shaded cell, the end output is throttled. So we'll talk about how to avoid the entire system dropping when we get to the inverter section, but to have a panel drop efficiency by 30 to 40% is a big deal. So this is another huge factor when we're building out these proposals for the customer, is determining the overall shading. It can cause a lot of issues down the road for the customer, including warranty issues if it wasn't properly factored in when we're building out the systems. Let me explain why. One of the main factors is directly responsible for the degradation of output of power is partial shading. Partially shaded cells produce less current than normal cells exposed to sunlight and behave like a reverse bias PN junction. As a result, it dissipates power instead of generating, and it gets heated. What happens to our electronics when they get heated? So we all have phones. Now our phones have a tendency to, it's too hot, and they shut off, right? We don't want the same thing to happen to our solar panels. The other thing that's happening is that one cell is now clogged, right? So it's kind of like kinking a hose for too long. If you have the same amount of pressure going through, voltage, and you put a kink in it, what's going to be happening over a period of time? Well, that cell is going to be pounded repeatedly until eventually it can cause some damage, right? So if we take a look at this drawing here, we have 1, 2, 3, 4, 5 panels that have all dropped production by over 30 to 40%, sometimes even more than that, because only 1 or 2 cells are shaded. That means all the rest of the cells are working just fine except for those specific cells. But because the entire panel runs in series, the entire panel now drops production because there's a kink leaving the very end output throttled to what the lowest producing cell is. So it works a lot like this. If you have an unshaded cell, it's 100% current and 100% voltage. If you have a partially shaded cell, the output current is directly proportional to the illuminated area of the cell. There's no voltage change though. So we say that's a good thing or that's a bad thing? Well, think about that hose. Too much pressure and it's going to burst. Now, a shaded cell, there's no possible output at all. A shaded solar panel will not function. It's the same as no sun on a cloudy day or night in general. If there's no sun, there's no production. So if you shade the panel completely, there will be no production. If you shade a cell, there will be zero production on that cell whatsoever.